Welcome to How Meets History. Today, we're uncovering why circuit boards are usually green and how that familiar color became a standard in the world of electronics.
You know, inside every single phone, computer, and gadget you own, there's a tiny, intricate city. And almost always, that city is a very specific shade of green. It's one of the most common colors in all of tech, but have you ever actually stopped to ask why? I mean, it seems like a simple question on the surface, right? But the answer is this fascinating mix of history, chemistry, human biology, and just pure practical economics. So let's peel back the layers on this iconic color. Okay, so the short and simple answer is that the green you're seeing isn't the board itself. It's a protective coating called a solder mask. But of course, that just leads to the real question, right? Why is the solder mask green? And that's where things get interesting. So before we even get into the whole color thing, we really need to understand what this layer actually does. The solder mask is a critical component, pretty much the unsung hero that keeps our electronics reliable.
So if you look at a bare circuit board, it's basically just a sheet of fiberglass with these delicate little copper pathways or traces running all over it. And that copper, when it's exposed like this, it's super vulnerable. But then you apply that solder mask and boom, it's totally transformed into the protected board we all recognize.
So what exactly is this stuff? A solder mask is a thin layer of polymer. You can kind of think of it like a really tough permanent nail polish that gets precisely painted over all those copper circuits. It covers everything except for the little pads where the components are going to be attached. And what it does is, well, it's actually got a bunch of super important jobs. It acts like a seal, protecting that reactive copper from oxygen and moisture, which would make it corrode. During assembly, it prevents drops of molten solder from accidentally connecting two points that should never touch, which would cause a short circuit. It also adds insulation and even makes the board a little bit stronger. Yeah, it's absolutely essential. Okay, so the mask is essential. We get it. But why green? You'd think there was some big committee meeting where they decided green was the perfect color, right? Nope, not even close. It was pretty much a total accident of history. And this quote really nails it. Green didn't become the standard because it was declared the best color from the get-go. It won out just because, well, that's how they made stuff back in the day. Let's do a quick history lesson. Back in the late 50s and early 60s, manufacturers started using these epoxy-based resins for protection. And it just so happened that the chemicals in those early, durable resins, well, they just naturally turned a kind of greenish color when they hardened. Then the US military, which was a huge customer, standardized on green. That got the ball rolling, and by the 70s, pretty much everyone was using green, so it just became the cheapest and easiest option out there. And believe it or not, that cost factor is still a huge thing today. The entire global supply chain is set up for green, so it's the cheapest baseline. If you want to make a board in any other color, blue, red, and especially black or white, you're going to pay more. Sometimes a lot more, like more than double the price, because it's a different process. So, to recap, green was an accident that became cheap. But here's the kicker, the really wild part of this story. It also just so happened to be the perfect color for the job. And nobody planned it. Yeah, it all comes down to our own biology. Our eyes have evolved to be most sensitive to the green part of the light spectrum. It means we can see more shades of green and pick out tiny little details against a green background better than any other color out there. So think about it. If you're a technician who has to stare at these tiny, complex circuits all day long, that green background is a massive help. The contrast is great against the silver solder and white text, so spotting tiny mistakes is way easier. And maybe most importantly, it's just way easier on the eyes. Less strain, less fatigue. All right, so green is a win for human eyes. But let's be real, today most of this inspection isn't done by people anymore. It's done by high-speed machines. You'd think robots wouldn't care what color it is, right? Well, wrong. Turns out, they kind of do. The process is called Automated Optical Inspection, or AOI for short. Basically, a machine snaps super high-res photos of every single board that comes off the line. Then software compares those pictures to an image of a perfect, golden board. Any little difference, a component in the wrong spot, a bad solder joint, gets flagged immediately for review. And here's the thing. The cameras and the software in these AOI machines, they've been trained and fine-tuned for decades on, you guessed it, green boards. That specific shade of green gives the software a perfect, clean background to work with, which makes its job way easier. The result? It's faster and more accurate at spotting problems. We're talking up to 30% more efficient in some cases. Another happy accident. Okay, so green is the king because it's historic, it's cheap, and it just happens to be perfect for inspection. But hold on, the story isn't over yet, because the world of circuit boards is actually getting a lot more colorful and, way more importantly, a lot more sustainable. These days, you can find circuit boards in pretty much any color you can imagine. You'll see that cool matte black in a lot of high-end gadgets, mostly just to look awesome. And white is super common for LED lights because it helps reflect light, which makes them more efficient. So now, different colors are chosen for specific reasons, whether it's for looks or for function.
But the biggest change happening right now has absolutely nothing to do with color. It has everything to do with this number. This year alone, in 2024, we're on track to generate 67 million tons of e-waste. To put that in perspective, that's like the weight of almost 1,000 cruise ships. It's staggering.
And here's what's really scary. Less than a quarter of all that e-waste actually gets recycled properly. Most of it, the vast majority, just ends up in landfills, and circuit boards are one of the nastiest and hardest parts of that whole mess to deal with. So you see, the big issue was never the green pigment. The real problem is the material the board is made from, that fiberglass and epoxy resin combo. It's a mix of stuff that's just almost impossible to take apart and recycle. But that is finally starting to change. You've got these innovative companies like Papershell and Jiva Materials with their Solo board, and they're creating a whole new kind of circuit board. These new boards are made from natural materials that can just dissolve in hot water or be composted, which means we can get the valuable parts back and get rid of all that toxic waste. It's a game changer. And this isn't just a small tweak. We're talking about a complete rethinking of the very backbone of our electronics. The goal is to solve what people are calling a silent climate crisis that's hiding inside every single device we own. So, that iconic green circuit board, it tells this incredible story of a happy accident, of history, and some really practical science. But looking ahead, it's also become a symbol of a huge challenge we face and, a huge opportunity to innovate. So the question isn't just why is it green anymore? The real question is, how do we make it truly green?
Don't forget to like and subscribe for more How Meets History.